This is a AIPMT 2015 question about circular motion. The problem is like this. A mass m revolves in a circle of smooth horizontal plane with a velocity v0 and a radius r0. This mass is attached to a string which passes through a smooth hole like this. The tension in the string is increased gradually, so finally it moves in a smaller circle. Now it's not moving in r0 circle but moving in a different circle of radius something like r0 by 2. In that case, what is the final kinetic energy of that particle is? That's what the question is, right? The first thing is, being a body is in circular motion, as particle is in circular motion, and no external torque is acting. Its angular momentum L is conserved. Angular momentum is something like moment of momentum. Moment of means product of distance of r of momentum is mv. So angular momentum is having a formula mvr. Or I can derive the angular momentum using the other way, this formula from the other way. We know angular momentum can be expressed as moment of momentum d by dt of moment of momentum. Well, let us consider another way. Let us not talk this about this way, but we can say angular momentum L is equal to, we know the formula I omega. We have written I omega is conserved I1 omega 1 equal to I2 omega 2 for a conservation of angular momentum. In the place of I can write generally mr square. In the place of V, omega, as V equal to r omega, omega can be written like V by r. So in the place of omega, I can write V by r. One r can be cancelled. I'll still get angular momentum equal to mvr. So the formula for the angular momentum is mvr, and as there is no external torque acting, angular momentum L is conserved. L initial equal to L final. L initial is m v0 rotating in a radius r. L final is m is same, v would be different because it is rotating in a different circle of radius r by 2. So m and r can be cancelled. v0 equal to v dash by 2. That implies new velocity equal to 2v0. We got the new velocity. Then once you got new velocity, you can get final kinetic energy. Final kinetic energy is half m final velocity square v dash square. That is half m v dash means we have proved that 2v0 whole square. Half m 4v0 square. This is 2. So final kinetic energy is 2m v0 square. Option number C is correct. That's how we get to the answer. So to solve this problem, you need to know one basic thing, that angular momentum L equal to mvr. And when there is no external torque acting, angular momentum is conserved. Basing on that, we got final velocity in terms of initial velocity, and a normal kinetic energy formula half mv square I have used to get to the answer. That's how we need to solve the problem. Thank you for watching.